Okay, the last part of 3A is abuses of percentages, and these are just some common things that you're going to find that for those people who have not taken this class can possibly be taken advantage of. The one I want to focus on the most is the shifting reference values. And that doesn't make a whole lot of sense, but really what it is something exactly like you see. Okay. At the store, they mark up an item 40%, then they say it goes on sale for 40%. After the two changes, it's tempting to say that the price of the item is unchanged. That is not true, and that's because the reference value has shifted, and we're going to show you one with that with salary. The other one is that the advertising you will see the most is in this first example here is about the jeans. It says, you see the sale advertised that it's 30% off, and then you get a coupon in the mail that says take an additional 30% off. Well, you know, if you think you're getting 60% off, you're incorrect. So let's talk a couple of examples and show how both of these work. Okay, so the first one does talk about a pair of jeans. It's on sale for 30% off the original price of $80. You have a coupon for an additional 20% off the sale price. Okay, so let's start with our starting value, and I'm going to go back and do circles on this too. Okay, this is the original jeans. Which is $80. So that's the whole circle. Okay. So we're taking 30% off, which means we are going to take a 30% or a third of it off. Sale. So what we're looking at here is we are looking at our compared value is going to be %70, 100% minus the 30. Okay, so we know how to calculate that. We know that 70% of $80 is the sale price. So I have 0.70 times 80 equals X, and that tells me that X is $56. So that takes care of this. Here's where we get into trouble. You now have a coupon for an additional 20% off the sale price. So when we do our new circle here, for the second part of the sale, this is the sale price, which is $56. And then we take a 20% off of that, so what we're seeing here now is now our compared value is 80% of the sales price. So we have 80% of 56 is the final price, which means 0.80 times 56 is X. So the actual final price is $44.80. Now, if you were an unwise consumer, then you would think, okay, well, if I get 30% off and I get 20% off, then I'm getting 50% off. Well, and we can do this in our head. 50% of 80 is $40. So we're ending up paying more than what we thought we might have to. Okay. All right. So let's see. Because of losses by your employer, you agree to accept a temporary pay cut of 10%. Your employer promises to give you a 10% pay raise in a few months. Will that restore your original salary? Okay, let's look at that and see. And once again, this is going to be a shifting reference value. So we're going to start out, and let's just pick a salary that's easy to work with. Okay, so your original salary, and let's just make it easy. Let's make it $50,000. And they are going to take away 10% of this. So we're actually going to, our compared value is going to be this portion here. So our compared value is 90% of the original salary. So we have 0.90 of our original salary is our new salary. So our new salary is $45,000. Okay, so that takes care of the temporary pay cut of 10%. But then he's going to give you a pay raise after a few months. But this is now, as you go to the next phase of it, your current salary is $45,000. So he's going to give you that plus 10%. So we're going to have the 100% plus the 10%. So now the compared value is 110% of the current salary. Convert that to a decimal. That gives you 1.10 times 45,000. Which brings you back up to 49,500. So you don't make it back to your original salary. Okay, so be careful of that kind of thing. I hope you don't ever have to experience that. I did during the 80s. Okay, the second one is less than nothing. And this one just makes sense, and this is one that I haven't seen very frequently. All right, so if you have an original pair of jeans that cost $80, what does it mean if the jeans are 50% off the original price? That means that the cost 50% off, that means the cost is 50% or $40. We can do this in our head. If it's 100% off, that means you're going to subtract 100%. That means the cost is 0% or free. They don't cost a thing. What would it mean if the jeans were 150% off? That's not possible. This is not possible. Okay. The most you can get off is the most you can discount is 100%. In essence, what this would mean, that if you got 150% off the original price, every time they would owe you $40 for every pair of jeans you bought. And if you ever see an advertisement like that, go get it, because they have to honor it. Okay. Unless it's a mistake, this doesn't make any. You just don't see it very often. But it's one of those things. If it seems too good to be true, it probably is. All right, and our last one is that you can't average averages. Now, this one deals with baseball statistics. In baseball, the batting average represents the at-bats, the percentage of at-bats in which you got a hit. So it's going to be hits divided by at-bats. Okay. So let's see. A certain baseball player got a 20% of his at-bats during the first half of the season and 40% of his at-bats in the second half of the season. Okay, is it safe to assume that he got hits on 30% of his at-bats for the entire season? Well, at first blush, yeah, you've got 20%, you've got 40%, halfway in between that is 30%. But here's where you have to figure out what you're doing for your hits versus at-bats. Okay. So for the first half of the season, he had 500 at-bats. %20 of those hits were 20%. So we want to know how many hits. Well, this, of course, would be my reference value, the 500, and this would be for my compared value. So what do I have to do to set that up? I have to say 20% of the 500 at bats is the number of hits. So that gives me 0.20 times 500 equals X. And if I multiply that, that means 100 is my X. Now in the second half of the season, let's look at that and see what happens. He had 200 at-bats, and he got hits on 40%. So that means I need to find 40% of 200, which becomes 0.40 times 200, which equals 80 for his hits. All right, so how many at-bats did he have? Well, we had 500 and 200 is 700. How many hits? 100 plus 80 is 180. Did he make his 30% of at-bats? Well, there are two ways to look at this. We can find 30% of total at-bats, which is going to be 0.30 times 700, which gives me 210. Well, he only got 180, so the answer is no. Now, the other way you could figure that out is just by hits or at-bats. So he got 180 hits divided by 700, which is 0.257 or 25.7%. So his average for the whole season was 25.7%. Now the reasons it's different is because because these reference values are different. If these two values were the same, then you could do it. 20% of 500, 40% of 500, that would give you 30%. But since these reference values for the two calculations have changed, then that's a problem. Okay, so let's see if we can identify these as either shifting reference, less than nothing, or don't average averages. Team wins 40% of its game in the seasons and 60% next season. It will have a 50% win rate over the 2 period. I'm going to say that's a 3 because you don't know how many games. The number of games. Each season is unknown. If elected, a politician promises to cut taxes by 20% for each of the first 3 years for a total of 60%. This is 1. This is not a shifting reference value. He would take 20% off the first year, and then that changes the reference value, and then 20% of that changes the reference value, and 20% of that. An advertisement claims that the energy efficient bulb uses 200% less energy. No, that can't happen. All right, a stockbroker makes this claim. I admit the value of your investments fell 60% last year. This year, however, the value increased by 75%, so you're now 15% ahead. No, this is a shifting reference value again. He lost 60% from its original value, then that changes to the reference value, and they're gaining 75% on that, so it doesn't add up to 15. And then finally, I've decreased my calorie intake by 125%, which has helped me lose weight. You know, you can the least calories you can intake is 0, which would be a reduction of 100%. So this is going to be a number 2. Okay, we are finally done with 3A. See you next time.